Alright, so finally finishing this test this morning. Everything goes right. 36, which graph represents the polar equation r equals 3 sines of 4 theta? That should be B, but let's check it. The question whether we're going to get to these and do them by hand or not. But anyways, I am going to go to mode. I'm going to put the calculator in parametric mode. And then I'm going to go back to y equals, and I'm simply going to type in, sorry, not parametric, bad start, polar mode. There we go. And now the thing is in polar mode. So 3 sines, and you hit the X key, she's a theta, and we want 4 theta. If memory serves me right, this is a petal, 8-petaled flower. It looks like it's got 8 petals to me. Alright, determine the value of x to make the following equation true. The straight bars mean determinant. If it was just a matrix, it would look like that. That's just a matrix. But the straight bars mean determinant. And there is a way to do these by hand. I'm not going to mess with it. I am going to simply plug in numbers. And that's what I'm going to do. I'm going to plug in numbers. So the first one is a 3 by 3. And I don't know what the right answer is here. I'm just going to try 45 over 4 for no good reason. So I'm going to let that x be 45 over 4 in both matrices. I know it's not 8 because I already tried 8 earlier. Just trying to speed these videos up a little bit. There's also matrix B. She's a 2 by 2. And again, I let the x be 45 over 4. Alright, let's see what the determinant of each of those matrices is. So second matrix, math, det. When x is 45 over 4, the determinant of matrix A is negative 33.75. Let's see what she is for B. Oh, that was close, man. Oh, that was close. So close. Alright, so I know 45 over 4 doesn't work. Now let's try 51 over 4. I probably should check to make sure I didn't have any typos too. Alright. I don't feel like retyping everything. Alright, there's the determinant of A. Not her. Bummer. So I'm basically down to choice C. Or A. I haven't done A yet. Probably should have started with A. Choice C is 90/14. Really don't want to do this by hand. Determinant of A is a funky looking number. Please be the same funky looking number. Sweet. So it was 90/14, and I did no algebra. I just knew how to push buttons. Identify the equation corresponding to the polar function r equals 2 cosines theta. That is a circle, believe it or not. When we do polar equations, obviously I'll show you how to do these by hand. It's not that hard. You actually are both sides. Anyways, we have a calculator. So I'm going to go to y equals, and this time I'm going to put in 2 cosines theta. And I'll do a zoom square. That way you actually see the circle. And there she is. She's a teeny tiny itty bitty bitty little circle. But, we'll zoom in. You can see that she has a radius of 1 and she's been shifted right. So radius is 1 and it was a shift right 1. That's choice A. Because, you know x minus h squared plus y minus k squared equals r squared, right? Hope you do. Alright. Determine the partial fraction decomposition of this function. I haven't taught partial fraction decomposition in years. I haven't taught it since I taught calculus. And that's usually when it's taught. So we is going to cheat. Because I am not teaching you partial fraction decomposition right now. I am going to make up a number. I'm just going to do something funny. Like I'm going to take pi and I'm going to store it to x. Oops. Let me get back into function mode here. There we go. Function. Take pi, store it to x. Then we're going to type everything in. You know, there's a lot of things kids don't realize they could do. I can't tell you if I was 17 years old and I saw the word partial function decomposition, if I would have even thought about numerical equivalency. I don't know if I would or not. But that's what it is. It's that they're breaking this thing into all of its distinct parts. It's useful in calculus to some degree. Now, why one wouldn't just do the quotient rule is beyond me, but whatever. Anyways, that's the number I get when I type in the original function. And these are equivalent. This is where you've broken it into its various factors. The text turns out if you put all this stuff together, you get that thing. You know, who would have thought? Anyways, it's 6 over x plus 3 divided by x minus 5 plus parentheses. By the way, if you're not that good with parentheses, use math and num n over d. It's just quicker for me to use parentheses. So I have a tendency to use parentheses because I don't want to spend all day doing this. Same exact decimal. And here's the last one. I guess I did the parametric equation yesterday. I was thinking this day. Which the following vectors is orthogonal? Two vectors are orthogonal if their dot product is equal to 0. So dot product is not really that complex of a thing. It's basically in some degree substitution. I'm going to put a 2 there, I'm going to put a 3 there, and a negative 7 right there. So when you take the components of each and multiply them together. So we're going to have negative 33 times a 2, minus 55 times a 3, minus 33 times a negative 7. And we're going to compute that result real quick. It should be 0. It was earlier when I did it. I tried to work these out ahead of time so I could speed the video up this morning, because I have a busy day, and I didn't want to sit here and waste your time either. And yeah, the product is 0. So I know that these two vectors are orthogonal. So now I'm going to check the other one. Do the same thing. Negative 33. I is 5. Minus 55. J is negative 9. Minus 33. K is 10. See what that equals. Hopefully it's 0. We are about to do vectors if you guys will never finish your trig section. And vectors are not necessarily difficult. There we go. 0. So, this vector is orthogonal with these two vectors. And there you go. That is the TMTA 2022 practice exam. Worked out for all of them but one. I hope you can get 39 out of 40 right.